Well, here we are at DesignCon, last day. With me today is Rich Goldman from Ansys. Welcome here, Rich.
Thanks, Chuck. It's great to be here.
So what are you expecting to see here?
Well, I'm expecting to see kind of a revival of a trade show because for the past year and a half, we've been locked down on trade shows and have to do things through our computer screen at our desk at home. And so I think a lot of people are excited about getting out and being able to meet their colleagues and see what's actually happening.
So you've been following the land of chips. What does that market look like these days?
Well, for the chip makers, it's really good because the pandemic has caused a shortage of silicon, a shortage of chips, semiconductors, because people have acted a little bit differently than they had before, like the car makers canceling all their orders and then realizing that, oh, people are actually going to buy cars, so we need those semiconductors, and finding out that everyone being at home had bought a lot more electronics, and so there was a lot of demand for semiconductors, and the car makers had to go to the back of the line, which is causing a huge issue because you can't sell cars without the semiconductors in them. I think it's really good for the semiconductor vendors because it's raising the visibility of how much semiconductors are core to our economy and really every bit of it. So it's looking good for the semiconductor companies. I'm a little concerned that we have gotten this recognition of, oh, there's a problem with the supply line. And people haven't really recognized that the supply line in semiconductors is very, very, very long. It's not just build more fabs in my country. And if TSMC, where most of our chips, the majority of chips are built now more than anywhere else, if they had built all their fabs in Phoenix rather than Taiwan, we'd still have the same issues we're having today.
Really?
Yeah, sure. So it's not an issue of where the semiconductor fabs are built, it's an issue of securing your supply line. And so, once the chips are built in TSMC, whether it's in Phoenix or Taiwan, they then get shipped out to somewhere like the Philippines or Malaysia or Singapore to get packaged, and then somewhere else to get stuffed onto boards, and then somewhere else to get in a system, and then back to America. So you got to secure that whole supply line. To begin with, you need the manufacturing equipment that actually builds the chips. Those are millions and hundreds of $1 million machines by people like Applied Material or KLA. Luckily, they're located in places that are all friendly to us. So that's good. And we are putting more emphasis in government in supporting our domestic semiconductor industry, which I think is good. But what we really need to look at is make sure that we have that whole supply line secure. And I don't think there's a strong enough emphasis on that yet.
So how does the market catch up with that?
Well, we got to build more fabs, for one. That's clear, because there is a shortage of semiconductors. Okay, we build more fabs, that takes 2 or 3 years to come online. Fabs cost billions, tens of billions of dollars to build. That's a big investment. We used to be in this cycle of boom and bust, where the semiconductor was booming and there was a lack of capacity, so everybody built fabs at the same time. 3 years later, they come online, there's overcapacity and the industry goes into a bust. We got out of that by trusting TSMC for all of our fabrication and Samsung and Intel and Global Foundries to drive the leading edge instead of 50 companies doing that so they can control it better. I think there's some danger now with countries all over the world investing into their domestic semiconductor companies and building more fabs in their country because they think that's the solution. If those all come online at the same time in 3 years, I think there's a danger of us going back to that boom and bust cycle.
So what happens in the supply chain? We understand the semiconductors are here, but you deal like automotive. Car prices are going through the roof.
That's right. So that supply chain needs to be secured. TSMC is really an issue because Taiwan has some issues with being threatened by China, thinking that is their territory. Earthquakes, monsoons. So if you cut that supply problem, you're going to have issues. A few years ago, there was a fire at a plant in Japan. Worked out that was the only place that was supplying a certain material. And so that cut into the supplies. So we have to diversify. We have to diversify on the supply chain. You can't just get your chips from one place, you can't assemble in another place. That all has to be, first of all, understood. and then diversified across the globe, and more of it domestically, not just the chip fabrication.
Can you talk a little bit about simulation? Kind of, and you're deep into simulation.
Absolutely.
What kinds of things are you simulating?
Yeah, so that is what Ansys does, is simulation. So you need to simulate everything before you build something, because the cost of something being wrong now is so high. To go back to fix it.
You said you simulated the human body?
Oh yeah, we simulate the human body, absolutely.
How do you do that?
Well, you got to model it. So first, if you can model something, then you can simulate it. You can't simulate it without being able to model it. So you have to figure out every little thing about how a human body exists. And then the next thing is if you can model it and simulate it, you can optimize it. Now we're not going to optimize the human body, but we'll optimize things like pacemakers or medicine that goes into that human body and how that human body reacts.
Oh, so you can actually test something against the simulation.
That's right. Test it against the simulation.
So what else do you simulate?
So we'll simulate, for example, fluids. So if you've got a turbo engine you want to build, you can make it as efficient as absolutely possible. If you got an America's Cup yacht, you want to make it go through the water as fast as possible, you can simulate that.
So does anybody do stuff without simulation anymore?
Not the winners.
Great. Thank you so much.
Okay.